Okay, good morning, ladies and gentlemen. Okay, the date for today is January 10th, 2024, and the time is what time? It's almost 3 a.m. Okay, my topic for this morning will be a continuation of my long video format topic trigonometry, and this will now be lesson number 47. Okay, let's proceed. The subject matter that I will be discussing this morning will be long video format topic on trigonometry, and this will now be lesson number 47. The title of the topic will be the so-called the cosine law. The last time around, I discussed the concept of sine law, and next to that, I have given you two example problems on the so-called solution of oblique triangles using sine law. So for this morning, we will be discussing another concept of the solution of oblique triangles, and that is the so-called cosine law. Okay, let's try to bring out the three formulas needed in the so-called solution by using cosine law. And here, we got a designation. The designation of the sides will be small letter A, B, and C. And the corresponding opposite angles of this one will be capital letter A, this is capital letter B, and this will be capital letter C. So this should be the sides, and these should be the angles. So if I will bring out the formula, at least we now know what is ABC and what is big letters ABC. The big letters are actually the angles, and the small letters are actually the sides. So small letter A corresponds to big angle A, and small letter B will corresponds to angle capital letter B, and side C corresponds to the opposite angle of angle C. It is just something like this. If this is angle A, the side opposite this angle is actually side A. So if this is A, this should be A. If this is C, this should also be C. And if this is B, this should also be B. Okay? We could not say that this is angle B and this is angle A. It's not. So if this is angle B, this should be side B. If this is angle A, this should be side A. And if this is angle C, this should be side C. So the parameters on, or the what you call this, the variables on the given formulas will represent ABC and big letters ABC. Okay, this is the first formula. A square should be equal to B square plus C square. Okay? If this is B and C, this should be BC. Okay? And if this is small letter A, this should be big letter A. You got it, guys? So if this is side A, this should be angle A. And if this is B and C, they should correspond to BC. That's the first one. So you will not interchange the parameters, okay? The next one will be B square should be equal to, if the left hand side is B, of course the right hand side will be in terms of A and C, right? So this should be an A square plus C square. This is A and C, so this is minus 2AC. Okay, and since this is side B, this should be angle B. The third one, the left hand side is C square. So if the left hand side is C square, of course the right hand side should be in terms of A and B. So this will be an A square plus B square, right? Since this is A and B, this is 2AB. Okay, and since this is side C, this should be angle C. So these are the three formulas. Okay, it is the so-called cosine law. It means that in any oblique triangle, the square of any side should be equal to the sum of the square of the other two sides, okay, minus twice the product of that two sides times the cosine of angle A, and which this angle A is actually the so-called included angle. If we are considering B and C, the included angle between B and C is actually angle A. If this is B, side B, and this is side C, the angle included, this is side B, this is side C, the angle included between side B and side C is actually angle A. That's angle A. So I will repeat it again. In any oblique triangle, the square of any side should be equal to the sum of the square of the other two sides minus twice the product of that two sides, the other two sides, times the cosine of the included angle. The included angle between A and C for the next one will be angle B. A and C, this is A, this is C. The included angle between A and C is actually angle B. So this is angle B. The included angle in the third formula will be side A and B, right? So this is A, this is B. The included angle between side A and B is actually angle C. So this is angle C. Okay, I will repeat it. The square of any side in any oblique triangle will be equal to the sum of the square of the other two sides minus twice their product times the cosine of the included angle. Okay, let's try to bring out the so-called derivation. In here, I could bring out two right triangles emanating from the original right triangle. Actually, the original oblique triangle is this one. I will cover first this one. That's the original oblique triangle. Okay, I just drop a vertical line emanating from this vertex here. This is a vertical line. And again, I draw an extension of the horizontal line emanating from this. It's a horizontal line. So meaning to say, if this is vertical and this is horizontal, this angle here should be 90 degrees. Then I will try to represent this side here to be small letter m. So this is small letter m. Okay, so I brought out this right triangle here, the one with the dotted line in which the hypotenuse is side B. Okay, so this is M, this is side B, and this is H. The height of the oblique triangle will be letter H. For the meantime, we do not know the value. The second right triangle emanating from the original right triangle is the bigger one. It is this side here, plus this side, plus this hypotenuse. So this is, if this is M, this is side A, the total length of this will be side A plus M. For the meantime, we do not know the value of M, and so with the value of H. And the hypotenuse, considering this right triangle here, it will be side C. Side C. I brought out these two right triangles because in the so-called formulation of the equation and how to bring out the so-called cosine law, it actually emanated from these two right triangles here. Okay, let's try to continue. Using the first right triangle, using the Pythagoras principle. First side, second side, this is hypotenuse, this is a right angle. So we could use Pythagoras, right? The square of the hypotenuse should be equal to the square of the two other sides. So B square, the hypotenuse, should be equal to the square of M plus the square of H. Computing for H square will be B square. We put M square on the left, then we try to rearrange. So H square will be B square minus M square. We call this equation number 1. That's the algebra portion already. Using the second bigger right triangle, again, by using Pythagoras principle, the hypotenuse will be side C, the two other sides will be A plus M, and this is H. So again, by using Pythagoras principle, the square of the hypotenuse, which is C, should be equal to the square of a plus m, quantity square, plus h square. Solving for c square now will be equal to, we expand this one. This is a binomial, we square it. So it will just be, the first one will be the square of the first one. The middle term will be the product of a times n times 2, which is 2am. And the last part will be the square of m, which is m square, plus h square. We will replace this h square here by this value. Okay, so actually there is a quantity over here. Okay, and since we are expediting the solution, I just remove it. Anyway, this is plus. The sign of the terms inside will not change, right? So it will just be simply b square minus m square. This is b square. Sorry for that one. That's b square. And if we try to simplify this one, luckily this m square here cancel with this. This is plus, is minus, they are the same term. And if we try to simplify the resulting equation, it will be c square equal to e square plus b square plus 2em plus 2em. This will be, I'll call this equation number 2. Why I am calling it as equation number 2? I just mark it because if I would like to go back to the formulation of the cosine law, I will go back to the numbered equation, right? Okay, let's try to take, consider the first right triangle. This angle here is 180 degrees minus angle C. This is angle C, and the sum of this angle here plus angle C is 180, therefore this portion here should be 180 minus C, right? So this is actually 180 minus C. Okay, we'll take the cosine of this angle here. If we consider 180 degrees minus C, this will be adjacent side. This is hypotenuse. Okay, so if we try to take the cosine of this, it should be m over b, right? Adjacent over hypotenuse. So from this, by using the cosine of 180 minus C, cosine of the quantity 180 minus C equal to, it should be the ratio this side here over this. It is actually m over b. Okay? We must have to expand this one by using our knowledge of the so-called cosine of the quantity a minus b. Okay? We pass by that one. The cosine of the difference of the angles. Okay? It will be cosine. If this is minus, this should be plus, sine. Like what I said, cos, sin. Okay? Cosine, sine. So it should be the cosine of 180, which is the first angle. The second angle is angle C, cosine of angle C, plus sine of the first angle, which is 180, sine of angle C, equal to m over b. Okay? The expansion of this one is actually cosine, sine. If this is minus, this should be plus. And cosine of 180, it should be negative 1. Because the cosine of 0 degree is equal to 1, and cosine of 180 degrees should be equal to minus 1. They are opposite. So this is minus 1. Times cosine of angle C. I still on camera? Okay, plus sine of 180. 180 is actually a horizontal line. There is no, the definition of sine is should be opposite the vertical thing over the hypotenuse. But if it is a horizontal line, sine value will be 0. The sine of 180, is equal to sine of actually 0. This is actually equal to 0. So this is 0. Times sine of angle C, and this should be equal to the ratio m over b. But this is now 0. Okay, so this will be 0. So m now will be equal to b times negative cosine of angle C. So m will be negative b. There's a negative sign here. So since b is to be multiplied with this, it should carry the sign negative b cosine of angle C. We call this equation number 3. Okay. Well, we must have to substitute this is the value of small letter m back to equation number 2, so we could derive cosine law. So substituting 3 to equation number 2. So we'll go back to this. Then we will try to replace a small letter m by the value negative b cosine of angle C. So what will happen? C square equal to a square plus b square plus 2a, we are following this, times m. What is m using equation number 3? It's negative b, small letter b, cosine of angle C. So c square now will be equal to a square plus b square. This is a plus and a minus, so it will become minus. Okay, this is a, this is b, this is 2ab, cosine of angle C. So this is actually the first formula. Under cosine law, if the left hand side is c square, it is this. The third one, right? That is the square of c should be equal to the square of a plus the square of b minus 2ab cosine of angle C. This is side c, this is angle C. This is side c, this is angle C. So by following this, we will just interchange the variables. Let's try to place the value of the left hand side to be a square. So if this is a square, the right hand side should be in terms of b and c. Right? So it will be b square plus c square. This is b and c, so this should be minus 2bc. This is side a, so this should be angle A. That's the second equation. It is actually the first one. Right? And also, we are done with c square, we are done with a square. So for b square, if the left hand side is b square, what remains on the right will be in terms of a and c. So it will be a square plus c square. This is ac, so this is minus 2ac. This is side b, so this should be angle B. This is the third formula. Okay, that's it, guys. That's the so-called cosine law, and we got 3 formulas under cosine law. It's this. Okay? So, for those of you guys who would like to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. I am assuring you, you will get something from my long video format topics. Okay, good morning from Los Angeles.